All right. Well, let's dive in as soon as that little screen comes up there. So we gotta move then. If we haven't done 12.3, oh my goodness. Okay. So 12.2 wasn't too bad, maybe, for some people.
Too easy.
All right, good. That's what I want to hear. All right, so here we go, 12.3. So 12.3 is going to be the same kind of thing. It's just cranked up a level. We're going to have an A sub n formula and an S sub n formula. Okay, find the common ratio right at the first four terms. So now they're giving me a formula. The formula is A sub n is 4 to the n power. Notice n is up there in the power zone. So this is going to be raised up a level. So here we go. So n equals 1. I'll plug in 1. 4 to the 1, that's just 4. Plug in 2. 4 to the 2, that's 16. Plug in 3. 4 to the 3. You can use your calculator. 4 times 4 times 4 would be 64. And plug in 4. 4 to the 4th, 256. So there's the first four terms. So this sequence goes 4, 16, 64, 256, ... Good so far? So so pretty much like the last section so far, right? We're just plugging in n equals 1, n equals 2, n equals 3, n equals 4. Getting some numbers. And now, though, what's being added from term to term? Nothing, huh? Because if you say, well, there's 12 added there, that doesn't work for the next one. It's certainly not add 12 again, huh?
They're multiplying.
They're multiplying, yeah, so they're not. So notice the difference. This is not an arithmetic sequence. Let me write the two differences. So arithmetic, what we did in the last section, is adding or subtracting the same number each time. This is geometric. See, the title is geometric. Geometric, which means multiplying or dividing the same number each time. So it's just one level higher. Instead of adding or subtracting the same number every time, it's multiplying or dividing the same number every time. And what is it doing? It's times 4, huh? It's times 4, times 4. So every time is times 4. And that's called the common ratio. Now, why is it called a ratio? Well, because if you say take the second term over the first term, like the 16 over the 4, second term over first term, if you divide them, you'll get 4. Or really, if you divide any two terms. Like if I did 64 over 16, same answer, 4. It's the common ratio. Because it's what you're multiplying by. So if you divide, that's what you'll get, huh? So last time we had with arithmetic, we had the common difference. Now we have the common ratio before. Good? So we're just multiplying from term to term now instead of adding. It's basically the difference. So the other ones were arithmetic. Arithmetic's adding, subtracting. These are geometric, multiplying, dividing from term to term. So number 2 here. So the formula is -4, 1/5 to the n. So let's go ahead and plug in 1. So if we plug in 1, excuse me. Excuse me again. So if we plug in 1, we get -4 times 1/5 to the 1 power there. Now, what do you do? That's just -4 times 1/5. What do you do when a whole number is interacting with a fraction?
And then multiply by the denominator.
That's right. Make it look like a fraction. Put it over 1 and multiply top times top and bottom times bottom minus 4/5. So that's first term. Second term. Plug in 2, -4 times 1/5 to the second. Can you get that one? So that'll be -4. The 1/5 squared is 1/25. And then again, you put that over 1, so that would be -4/25. Yeah, so that can't be simplified any further. Right? Nothing goes into 4 and 25. So then we go n equals 3, -4 times 1/5 to the third. Use your calculator. So 1 over 125. Again, the -4 goes to the top because it's over 1. You get the idea, right? Just like that. Now, what's the common ratio?
Dividing by.
Yeah, so the common ratio. So how do we find common ratio again? Just take the second term divided by the first term. If you're not sure, if you can't just tell by looking, then just take the second term and divide by the first term. So what do we get? We get second term. This is the second term. This is the first term. So second term. So we're going to get minus 4/25 over minus 4/5. Good so far? And what do we do when we have a fraction over a fraction? Yeah, the one on the bottom flips up, right? So it becomes minus 4/25, and this guy flips up like that, times 5 over minus 4. That good so far? Just flips up like that. And then the minus 4's cancel. The two minuses make plus, the 4's cancel. So we get 5 over 25, which is 1/5. So the common ratio is 1/5. What's happening from term to term is it's multiplying by 1/5. And that's true, isn't it? To get from the first term to the second term, you multiply this by 1/5, don't you? It makes the bottom 25, and then you just keep doing multiply by 1/5 again, and it makes the bottom 125, etc. So that's what's happening from term to term. In other words, it's just the number that has the n on it. That always will. If they give you the formula, the number with the n on it is the common ratio automatically. So you can skip all this dividing second term by first term stuff if you just observe that. Is that good? But sometimes it'll be tricky. Some of these they'll make it in a real tricky way, so you will want to remember when you can't tell, you can always just do second term divided by first, and that will give you the common ratio. All right, so geometric, because it's multiplying the same thing every time, not adding the same thing every time. All right, so the formula is 4 to the n minus 1 over 2. So go ahead, crank out a couple of the terms. They want the first 4 terms, and then see if you can find the common ratio. So plug in 1, 4 to the 1 minus 1 over 2, 4 to the 0 over 2, 1/2, so first term's a half. Roberto's in the back here, Roberto. He's our tutor, just remind you. He's there to help you if you need help in these last 3 weeks of class. All right, plug in 2. And we get 4 to the 1 over 2, 4/2, 2. So first term's a half, second term's...
I can write that as 2 over 1 though, right?
Yeah, sure. And then n equals 3. 4 to the 3 minus 1 over 2. 4 squared over 2, 16 over 2, 8. Good so far? Then you could do the fourth one. I'm going to stop there and find the ratio. So what is the common ratio? Yeah, it's 4. Can you tell it's multiplying by 4 every time? If you're at all unsure, just divide any of the two. Any of the two consecutive ones, you know. So I'll just take second term over first term, right? Second, but you can do third term over second term. It doesn't matter. So 2 over 1/2. Second term over first term. Grab the denominator and flip it up. So it's 2 times 2 over 1, which is really just 2 times 2, which is 4, as we knew. So it is just the number with the n power on it. Whether it's n or n minus 1 or whatever, it doesn't matter. 4 is the ratio. Good, easy enough. Just multiplying the same number every time because it's geometric instead of adding, subtracting the same number every time, which is arithmetic. Okay, so 9 to the n minus 1 over 5 to the n. So I want to crank out, let's just crank out, I'm just going to crank out the first 2. Plug in 1, plug in 2. Find the first 2 terms, then you can just divide them to find the common ratio. Any guesses ahead of time? What do you think the common ratio is going to be?
9 divided by 5.
Yeah, they both have n on them, huh? It's 9/5. Yeah, that's correct. So plug in 1, you get 9 to the 1 minus 1 over 5 to the 1. 9 to the 0 over 5. 1/5. So the first term is 1/5. Right, anything to 0 power is 1, you know that. plug in 2. Oops, 2 minus 1. Over 5 to the 2. So that's 9 to the 1 over 25, 9/25. And you could find the third and the fourth. Let's go ahead and find the common ratio. So the ratio is second term over first term, 9 over 25 over 1/5. Good so far. Grab that 1/5, flip it up, 9 over 25 times 5 over 1, like that. And then 5 goes into 25 5 times, like we thought. The ratio, common ratio, is 9/5. Good? All is well? Okay, so they're saying the initial term is A. I don't know why they don't say A1 there. That's what I'm used to. I would prefer that, but for whatever reason, they changed the style in which they're writing it. So just remember, that is the first term. Even though they're not saying A1, they're saying it here. Initial term, first term, right? And the ratio, so now we have an R instead of a D, right? Before we had the D, the difference from term to term. Now we have the ratio. Whatever, that's the multiplier. So that means, here, let's do some of the terms. So the first term is 3. That's what the A is. That's what they're saying, initial term. And then you just, the R is what you multiply by each time. So I'm going to go times -8. So that'd be -24. Good, and then just do that again. Times -8. I need a calculator now.
That X confuses us because it looks like you're making that.
Yeah,
Just put like a circle.
good idea. Times -8 times -8. So, or maybe I should just draw an arrow. So, times -8 times -8. So, plus 24 times 8. So, 192. So, positive, huh? Because it's negative times negative. And then times -8 again. And that's something very big. 1536, negative. And then one more time, times -8. And I'm getting 12,288, and it's positive. See how they go positive, negative, positive, negative, positive? Because you're multiplying by a negative, so that just changes the sign back and forth. This is the first term, second, whoops, it's a funny second. Second term, third term, fourth term, fifth term, and that's what they wanted right here, right? They're asking for the fifth term. So there it is. I found the fifth term. Is that all they want? Find the fifth term. Oh, and the nth term. So they want the general formula. How are we going to come up with the general formula? Like, in other words, A sub n. Like an ability to find any term. Like if I suddenly wanted to find the 100th term or whatever. Like a CD kind of thing. So how can I find a formula? So here's the first term, second term, third term, fourth term, fifth term, dot, dot, dot. Nth term. So in general, how do you find the nth term?
AN equals.
Well, it's -8n something because you're multiplying by -8 every time.
Yeah, you're multiplying by -8 every time. Good thought. You know what might help you see it? Is if you wrote exactly and precisely what each of these is. Like, where did I get the -24? Well, it's 3 times -8, huh? And where did I get the 192? Well, I took the 3 times -8 squared, because it was another -8. See what I'm saying? Because it was 2 -8s to get to the 192. And then what's the 1536? 3 times -8 to the third, right? Because we have the original 3, and then times 1 -8, and then times 2 -8s, and then 3 -8s. Get the pattern?
Yeah.
So look at the relationship now. Whatever number is here, how does it compare to the number here?
The power.
One lower,
And minus
right? Whatever's here, one lower. See that? Whatever's here, one lower. Huh. So whatever's here, n minus 1. It's -8 to the minus 1 with a 3 in the front, isn't it? See how that's the pattern there? So So that's the nth term. That's the a sub n. Let me give you that. Having done that, let me give you the general formula by which we will always find all these geometric ones. It's a sub n is, what is this? This is the first term times
N minus.
the ratio to the n minus 1 power.
Okay.
Yeah, that's what it'll always be. Now, notice that similar. Remember the arithmetic one that we had? So I'll give you all these on the top of the next test. You don't even have to put them on your 3x5. The arithmetic a sub n was a1 plus n minus 1 times, or d times, how did I write like that? That's how I wrote, right? Yeah, so notice it's similar, huh? They're very, very similar. It has an a1, it has an n minus 1 in the d. This has an a1 and n minus 1 in the r. But notice everything is just cranked up one level. Do you know what I mean by that? Remember the order of operations? Please excuse my dear Aunt Sally. Adding, subtracting is the lowest level. Multiplying, dividing is higher. Then powers are higher than that. Right? So notice adding, a1 plus, a1 times. It went up a level from adding to multiplying. Notice n minus 1 is times the d. Now it's in the power zone. It went from times up to powers. So everything's just cranked up a level because the whole sequence is one level above. Instead of adding from term to term, you're multiplying from term to term. So in the formula, everything cranks up one level in the hierarchy. Yeah, Luis.
What kind of formula would it be if you wanted to alternate between positive and negative?
Oh, the R makes that happen automatically when it's in negative R. Yeah, we don't have to do anything special. That's why this alternates right here, back and forth, positive, negative, because the R value is negative 8. So if you multiply by negative 8 one time, you got negative. Multiply by negative 8 two times, it's back to positive, because 2 negatives is positive. Yeah, that happens automatically based on the R. All right, so there we go. So this is what I'll give you, as well as this one too. And then there's an S sub n formula for both of them. We haven't got the S sub n for geometric yet. That's what I'll give you at the top of the next test. So there we go. There's the first term. There's the R. It says find the fifth term and find the formula. So, yeah. So you could just find the fifth term and then find the formula. Give you a second on that. This time, all of a sudden, they're using A1 now. I don't know why they used A for a minute there. So A1 is negative 9, R is 4. So the first number is negative 9, and then you go times 4, huh? So negative 36 times 4. Too big for me already. The geometric ones get real big real fast, don't they? This would be negative, whoops, 2304. That's the fifth term. And then can you write the A sub n formula? It's A1 times R to the n minus 1. So it's A1, negative 9, times R. What's the R? What's the row? It's right here, 4, to the n minus 1. There we go. Good? Questions? All right. Yeah, so they're giving me a sequence. They're saying, okay, 3, 3/4, 3/16, and they want the sixth term. They want the sixth. So what's happening from term to term?
Multiplying by 1/4.
Yeah, everybody see that? Because this one's 3/1, huh? So they're just multiplying the bottom by 4 every time. Yeah, so I wouldn't do any formulas or anything. You know, I think if you do the show me example, they have you get the formula and then plug in 6. That's more work, I think. I would just go boom, 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 3 more steps, and you're there. So I would just say, okay, I'm just going to multiply by 4. So the next one's going to be 3, and then just the bottoms times 4 every time. 64, and then times 4 again, 256, and then one more, 1,024, and there it is. I would just do that rather than use a formula. I think they show you to use a formula. I would just do that. I mean, if they wanted me to go down to the 23rd term or something, yeah, it'd probably be better to use formula. But these geometric ones, they're not going to have you go very far because they get so big. So if it's just like 3 or 4 steps down the line, I would just do it by hand like that. Probably easier. Good on all that? Remember, the arithmetic ones, they'd have us jump like to the 100th term because they didn't get very big. So, yeah, the formula was helpful then. All right, so we've got 0.5, and then 0.05, and 0.005. This is the first term, second term, third term. And they want me to jump down to the 10th term. Can we do it just by simply following the pattern?
Yeah, divided by 10.
Yeah, I mean, I don't want to do all the steps in between. I don't want to do 4th, 5th, 6th, 7th, 8th, and 9th. I want to just jump to the 10th and be done.
Oh.
Can you do that? Look carefully at the pattern and just write the answer for the 10th. Look at the relationship between this number and what you see here. This number and what you see here. This number and what you see here. This number, and write something for me there.
10, 0, and 9.
Yeah. Divided by 10.
Do you see how it is? This has 1 0 in the front of the decimal only when the number 1 is there. This has 2 zeros. But, well, I mean, yeah, you could do it that way. This has 3 zeros, so this is going to have 10 zeros. 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So there's 9 zeros here, huh? And 1 0 there. So 10 zeros altogether, right? 1 0 in front of the decimal, 9 other zeros. 9 zeros after the decimal, right? Because on the 3rd, there were 2 zeros after the decimal. On the 2nd, there was 1 0 after the decimal. So on the 10th, there'll be 9 zeros after the decimal, huh? That good? Just follow the pattern. Write down the answer. All right. All right, so we've got 2, 8, 32, 128, So, what's happening from term to term, first off?
Multiply by 4.
Times 4, huh? Times 4 every time? Times 4. Times 4. So remember the formula. It's A sub n is A1 times R to the n minus 1. So it's A1, and what's A1?
2.
2, that's A1. 2 times R, this is R, 4,
4.
to the n minus 1, done. Good. And I'll give you this right at the top, that formula. Okay. Things everywhere. Okay, so minus 2, then 2/3, then minus 2 9s, then 2/27. Give it a try. So they want the formula. So really you need the R. It's all about the R. Be careful on that.
Easy peasy left.
Negative 1/3.
So if you're looking now, if you could just look at it and see it, great. If you're at all unsure what the R is, remember what you can do. R is always second term over the first. So really, you could just look at it. Maybe can you just say, how does this become that?
Times negative 1/3.
Times negative 1/3. Yeah, right. They just multiplied it by negative 1/3. So if you just look at that and say, hey, it's negative 1/3, great. You're totally right. If you're not sure, then do second term over first. So 2/3 over negative 2 over 1. Flip this guy up. 2/3 times 1 over negative 2. So the 2's cancel. There it is, negative 1/3, as we observed. So the R is negative 1/3. So then the formula, A sub n is A1 times R to the n minus 1. A sub n is A1. A1 is negative 2 times R, which is negative 1/3 to the n minus 1. Good? Easy enough? Your favorite section so far? Right. Well, we're at the 5th, so 4 steps back to get to the 1st. Yeah, right. So they're giving me the 5th term. They're telling me that the 5th term is 81. And I'm gonna walk back to try to find the 1st term. Right? Why am I going to try to find the 1st term? Because they want the formula. They want the A sub n, which I need A1 for, right? A1, R to the n minus 1, so I need A1 to do the formula. I need the 1st term. I need whatever's here, I need it. Okay, so to find what goes there, that first term, I need to find that. So how do I do that? Well, yeah, they're saying the r is -3, which means they're going times -3, times -3, times -3, times -3 every time. So to do it backwards, you would divide by -3, right? So that would be what? -27, and then divide by -3, positive 9, and divide by -3, -3, and divide by -3, positive 1.
Couldn't you just plug in what you know into the equation and work backwards?
You probably could. So is that right? 1 times -3 times -3, yeah, it's all good. So then the formula is a sub 1 is just 1 times r, which is -3 to the n minus 1. Good on that? Any questions on that one? Okay, so they're saying, hey, the A2, the second term is 8. I don't know the third. The fourth term is 1800. And of course, I got to find A1 to get the formula. So, let me let you think about it for a minute. How can you find out? They're giving you just those two pieces of information. You got to figure out the r, right? The thing that's being multiplied every time. Trying to find out what's being multiplied every time. Anybody have any way of doing this? Probably lots of different ways. I'm thinking of one, but you might have one.
1800 over 8, like divided by
So 1800 divided by 8, which would be 900, 450, 225. Is that what it is?
You do that in your head?
225.
Okay. So what do I do with that? What is that? Is that r?
And then,
That's what got me from here to here. R is what just takes me one step, huh?
so divide by
Divide
3.
by half.
Right? So this is not R. We agree? Because that's what takes you 2 jumps. R is what just takes me 1 jump. Times R, whatever the ratio is, huh?
No.
Well, how about this? Anybody got another idea?
Plug in what you know, and then 64.
What's that?
You could multiply 64 by 8.
So how about this? How about we take 8, what's this thing keep jumping on me? So take 8, and whatever R is, this is 8R, isn't it?
Oh, yeah.
And then
Sorry.
times R again, this is 8R squared. So 8R squared has to equal 1800.
Oh, easy peasy. And then divide by 8 and then take the square root.
Then divide by 8. We get R squared. See, R squared, this is R squared. This is R times R, in other words. So square root it. And R is 15. Does that make sense? So we used a variable, in other words. Does that make sense how I did that? On that? So, okay, so it's multiplying by 15 every time, isn't it? Multiplying by 15. Everybody okay with that? Again, I just said, well, this is 8, times R is 8R, times R is 8R squared. 8R squared is 1800. Solve for R. R is 15. So now, and then what is, what's here? What's
Divide by
A1?
15.
What is it?
Just divide by 15.
Just,
8
good job.
15s.
Just divide by 15, that's right. So this is 8/15, correct. Because if you take 8/15 times 15, it'll become 8, huh? Right, everybody see that? So then, yeah, so now we've got it. So the A sub n is A1, R to the n minus 1. So it's A1, 8/15 times R, what's R? 15 to the n minus 1. There's the formula. You can do that now, right? Now that you've seen it once. Kind of looks like a little trick. Once you've seen it, you got it. A lot of math is little tricks like that.
So if we had, if the 1800 would have been on like
Further
the
down,
third, it would be like, you can use that as a third.
just go times r times r times r, however many r's. Yeah, cube root it or whatever. Yep, you're totally right, Luis. You got it. Yep. However many jumps down is how many times r, and then just equal to whatever the number is and solve cube roots. Yeah. Formula, because I don't remember the formula. This one's a little messy. So we need a formula. So now they're adding. Notice it's a sum now. So we're going to have an S sub n formula for geometric like we have an S sub n formula for arithmetic. So S sub n is, I don't know. Gotta look it up. S sub n is, there it is, A1, that's a funny looking A. A1 times 1 minus r to the n over 1 minus r. I'll give you that as well at the top of the next test, so you don't have to put it on your card. So you'll have both A sub n formulas and both S sub n formulas for arithmetic and geometric at the top of the next test. So there it is. There's how you sum up a bunch of terms with that formula. Okay. It's a little tricky to use this one, though. He can be a little tricky. Let's give it a try. So so they're saying, so right here, there is the A1. So right there goes the A. So S sub n equals the A1. What's the A1?
1/9.
Yeah, that's the 1/9. That's the first term, huh? 1/9. Okay. And then something to the n minus 1.
7/9.
Am I gonna have to divide?
We're going to have to do some stuff. Yeah. What's the R? How about that? We better take this and do some algebra. What's the R?
7.
Good job. 7. So everybody see what's being done from term to term here? A lot of times people get confused by the 9. I'm glad you're not getting confused. Only, remember, because it's only about what's changing, huh? The 9 is not changing. They've all got a 9. What's changing is what's happening on the top. It's an extra 7 every time. So they're just multiplying by an extra 7 every time. The R, if you're not sure, just take second over first. Second term is 7/9 over the first term is 1/9. Flip this up. 7/9 times 9 over 1. 9's cancel, 7. So sure enough, the R is 7. They're just multiplying by another 7 every time. Okay, so what? Well, then this formula, whoops, I'm kind of scribbling it. This formula is going to be S sub n equals A1, 1/9, times 1 minus r, which is 7 to the n, over 1 minus 7. Everybody good so far? I just took that formula, plugged in A1, and plugged in r. Okay, now I need to make this look different so that it fits this format. It's got to have something to the n minus 1. How can I make this look like that without changing its true value? So a couple of steps. Let me help you with that. The bottom, just make that 1 minus 7. That's just negative 6, huh? And then just multiply 9 times negative 6. Since they're both in denominators, just multiply them together. So you get 1 over negative 54. Good so far? Is that too quick? Everybody see what I did? I just said, okay, I got to make it look like that. So this has no denominator. The denominator is only in the front. So I said, okay. So I'll just subtract 1 minus 7 is negative 6, and then 9 times minus 6, just the two denominators multiply, minus 54, just put that in the front. That good so far? Now, I'm almost there, right? The format is something in the front. I got something in the front, that's good. And then something to the n minus 1. Something to the n, well, it's kind of reversed, isn't it? So I've got to reverse this to make it look like that. How can I reverse it? If I just simply reverse it, if I just go, look, it's just 1 over minus 54 and just reverse it. Well, that's different. That'll change it. I can't change it.
That's a
Times by
negative.
negative
It's
1.
negative 7.
Good. Yeah, you know when you flip the order of subtraction, it's a negative 1. Just think about any numbers you want, like 6 minus 4, that's 2. If you reverse it, it's negative 2, huh? It just changes the sign to reverse the order of subtraction. So if I reverse that, then that puts another negative in the front, which makes it 1 over positive 54, huh? And there we go.
We can see it as multiplication of negative 1 over
Yeah, I multiplied this and this by negative 1. How about that? I multiplied two negative 1s, which is positive 1 and no change. Exactly. I multiplied this by negative 1, flipped it around, and this by negative 1. So I did two negative 1s. I did no change, really. I just made it look different. Is that good? So this actually is going to become 54, 1 over 54, and this would be 7 to the n minus 1. That would be the S sub n formula made to look like they want it to
Can you
look.
explain that a little slower, Mr.
Yeah.
The whole multiplying right there.
Yeah, so I basically, so first off, I did the bottom, minus 6, multiplied those together, minus 54. That got rid of the denominator, because I wanted no denominator in the parentheses. So that brought it, I just brought it all to the front. And then, to change this, the order, I just multiplied by negative 1 twice there. I just said, look, I'm going to take this guy times negative 1, and I'm going to take this guy times negative 1. If you multiply negative 1
That's
twice,
the same thing, yeah.
another way of saying the same thing, yeah. Then it turned this around and made that positive. So really I made no change. Just looks different. Right, that's like taking 2 times 3 and saying I'm going to make them both negative. That's still positive 6, huh? I haven't really changed anything. All right, a little trickery there, huh? All right, so we're back to the sigma notation, which you know means sum. From k equals 1 to n of 2/3 to the k. Okay, so again they're asking me to put it in the S sub n. So let me write, and certainly this is a big Greek S. So on an exam, on the next exam, when you see the big Greek S, you know you're going to use one of the S sub n formulas, right? Because, you know, the Greek S, the English S, they go together. They both mean sum. So for sure I'm going to use the S sub n. How would you know, by the way, that this one's geometric? It won't say, hint, I'm geometric, not arithmetic.
Because it's multiplying by the power.
K is climbed into the power zone. Yeah, when you see K up there in the power zone, like that, you go, oh, it's arithmetic, geometric. So then you'll have this at the top of your paper, A1, 1 minus R to the n over 1 minus R. So, okay. Now, what's the, we need the R, and we need the A1. So you know what I suggest? Let's just crank out 2 terms, and then we can tell what the first term is, and we can divide the 2 of those, or just look at them and tell what the R thing is. So let's do 2 terms. So this formula, 2/3 to the k, let's plug in k equals 1. K's our variable here, right? The k's up here. So that'd be 2/3 to the 1, which is 2/3. And if we plug in k is 2, we get 2/3 to the second, which is 4/9. So there's the first 2 terms. Everybody good so far? Yeah, so what's happening every time? What 2/3 times what, you know, what's going to make it into 4/9 times what? Another 2/3, huh? Everybody see that? So the R is 2/3 and the A1 is also 2/3. They're both 2/3. Good so far? Am I going too quick? So then this formula here, bring it down here. So S sub n is A1. There's A1. 2/3 times 1 minus R. What is R? Also 2/3. We good to there? It's a big mess. We're going to have to do a bunch of fancy algebra on that thing to make it look the way they want it to look. Good so far, though? So, how are we going to make this look like that? First off, we got to do something about that denominator. Oh yeah, let's just let this 3 distribute through, huh? Right? The 2 denominators just multiply each other, right? So I'll leave the 2 on the top. The 2 denominators are just going to multiply each other. So and I'll leave the parenthesis thing in the front. 1 minus 2/3 to the n. Just leave that in the front. 2 denominators multiply. 3 times 1 is 3. Right? And then 3 cancels that. 3 minus 2. Did that make sense? It was 3 times 1 minus 3 times 2/3, and these guys cancel.
Oh, yeah.
Is that okay? Everybody see what happened there? So I let the 2, we always pretty much do this. We let the two denominators multiply. That 3 went to the 1, 3 times 1 is 3. And the 3 went to the 2/3, and the 3's canceled here. That's 3 minus 2, or just 1. So this will become 2 over 1. This is just 2, huh? 1 minus 2/3 to the n. Good so far? This is 2 over 1, really. It's just 2. 1 minus 2/3 to the n. And then the last thing is just that same, oh no, they put the 1 in the front this time. They keep changing their mind. We're done. I was going to turn it around again, but all of a sudden this time they're all schizophrenic. Now they like the 1 in the front. They're just playing games with us. So this time they want the 1 in the front, so we're good. That's it. That's exactly the look they want this time. Is that okay? See how I changed it to have that look? So again, I just multiplied those two denominators together. The 3 went there, the 3 went there. 3 times 1 is 3. 3 times 2/3 canceled. 3 minus 2 on the bottom, which is just 1. So 2 over 1 is 2. All right. All right, so there's a bunch of numbers, and they want us to find the S sub n. So let's start by writing down the formula. Again, oh, how would you know this is geometric? What's being done from term
Multiplying by
to term?
positive 11.
Times positive 11, well said. It's times positive 11, right? Because the R is second term over first. If you're not sure, if you're at all unsure, take the second term over the first term, negative 11 over negative 1, positive 11, yeah. So we're multiplying by positive 11. All the terms are negative just because they started negative, huh? And they stayed negative because we multiplied by positive number every time, positive 11. So A1 times 1 minus r to the n over 1 minus r. So A1, negative 1, good. This is A1 there, first term, times 1 minus r, r is 11. Good to there so far. And maybe they would let us, well, no, we got to do some.
I
What?
think put an N at the bottom too.
Oh yeah, why did I put it in? That's wrong.
Wrong.
Thank you. Okay, yeah. So now, the bottom is negative 10, right? Just 1 minus 11, negative 10. Yeah, and then I would just bring this guy over here. So it'd be negative 1 over negative 10. And then you can leave the other part separate. See what I did there? I pretty much always do that. That's the look they want. Because I grab that denominator, just combine it. Really, there was like a 1 over there, if you want, you know. I just combine those two together. And then two negatives, positive. So positive, regular 1/10, 1 minus 11 to the n. There we go. Oh, wait a minute.
It's asking for the sum though.
Yeah.
And we don't know what the sum is because it's.
Yeah.
Isn't it? Aren't we going to be using the arithmetic one, where we the first one plus the second one, plus the last one?
Are there in terms?
It says the last term is negative 11
Yeah. What does that mean? By 11 over 1. Yeah. Okay. Yeah. Okay. This is the answer, but it's a little tricky to see it. Let me show you. How many terms are up there? There's actually n terms, even though the last one is n minus 1, which might lead one to think there's n minus 1 terms. Are you tracking with me? What you want to do is you want to see the power structure. What do I mean power structure? Because this is in the power zone, right? So you want to compare. This is 11 to the first power, isn't it? And this is 11 to the second power. 121 is 11 times 11. Do you see what I'm talking about? This is 11 to the n minus 1 power. So if I say, hey guys, I'm going to count 1, 2, so hang with me in our last minute, get this concept. If I go, hey guys, I'm going to count, here we go, 1, 2, 3, 4, 5, 6, 7, 8, 15. I stop at 15. How many terms have I counted? 15, obviously, silly question, right? What if I go, okay, 1, 2, 3, 4, 5, and I stop at n minus 1? How many terms have I counted? N minus 1. N minus 1. Okay, but what if I start at 0? Now how many terms are up
N
there?
minus 2?
That's 1 more, so now there's n. 1 more than n minus 1.
Yeah.
Am I losing you? This is a subtle concept. It's important. I know it's the last minute and you're thinking about whatever's next. But hold on for a minute. This is an important concept. It's tricky for people. This exactly tricks them. So if I start at 1, if that 0 is not there and I start at 1, then wherever I end, well, that's how many there are, n minus 1. But if I add an extra one, like say I start counting at 0, that means that total number of terms there is actually n now, one more than the ending number, right? Like if I go 0 to 8, for example, if I go 0 to 8, there's 9 terms there, huh? Because 1 through 8 is 8 and one more is 9. See what I'm saying?
Yeah.
So if you start at 0, there's always one more than your ending power. Well, did I start at 0? Yes, this is 11 to the 0. Do you see how the power is like a tick counter, right? 11 to the 0, 11 to the 1, 11 to the 2, blah, 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 11 to the n minus 1. So there's actually n terms there, which means this is the right formula to use, because that's the sum of n terms. So that's all to say, that's the right answer.
So the answer is N.
They're going to trick us on the ones to come. They're going to like make it n instead of n minus 1 and fancy things like that. No, the answer is this. It's straight ahead. But tricks are coming next time.